So all of them, see, all of these will, if you want to be an absolute master at all this, so you have to keep practicing, right? Then what I have shared with you is the basic knowledge, basic understanding, and obviously some advanced concepts also. Next, we will go to what is a package, right? So this is another most important and most regularly used object type of Oracle. Okay, whenever you work in any official capacity, not in your personal uh, database or anything, any official database which is being used in some production website or something, you will see lots of packages. Okay, so what is a package? Package is a schema object or a database object. Okay, you know what a schema is? Do you know? Do you know what a schema? Yeah, yeah. Okay, so you've been studying. Good. So schema is nothing but a user. So one a schema object means something which has been created by a particular schema or a particular user, and then can be manipulated. I mean, only as per the user's wishes. Whatever whoever else he has given whatever privilege, that in that fashion only the object can be manipulated, read, write, or something like that. We have already discussed that, right? User roles, privileges, that one. Okay, fine. Yeah, that understanding is clear. Schema is nothing but a user. Okay. So a package is a schema object that groups logically related PL/SQL types, variables, and subprograms. Okay. Now, now a package doesn't automatically go and find out which subprograms or which types are logical related. We create the package in that way, right? So there are various advantages of or benefits of packages. We will get to that later. Let's first see what goes inside a package. Okay, package has two parts: package specification and package body or definition, right? So these have to be these are two different sources, right? So if you have a package ABC, it will have a separate source called package specification. It will have a special separate source called package body. Okay, what goes in the package specification? Package specification is the package interface which declares the types, all these things which are uh, I mean, which are there, which the package contains, right? Types, variables, constants, exceptions, cursors, and subprograms that can be referenced from outside the package. All objects in the package specifications are known as public objects. So, what does the package specification consist of? It consists of just the names. Okay, if you can say you have three procedures and two functions in your package. So in the package specification, you'll only have the names of the three procedures along with its parameters. Okay, just the names and the parameters, in out parameters for all the procedures, functions, and everything. If you talk about variables, constants, just the name and obviously the data type, right? When you declare a variable, you just give it a name and then the data type, right? If you want to give the default value, you can give that also. Cursor, just the name. So we are talking about package specification. So it just consists of the names along with the uh, parameters wherever required, right? So all objects in the, okay, so this is kind of like a package specification. How do we don't call it as package specification, we just call it as package. Okay, if I say create package, that means it means the specification. Okay, so here I am creating a package with a single procedure, that's all. Okay, it is, yeah, this is where it is done. What is this? This is something else. This is confusing. So here, what am I doing? I'm creating a package called emp underscore sal. and I'm putting one procedure, one single procedure with find underscore sal with the input parameters in it. Okay. Parameter, if I am not, by default it is in, right? So this is an input. So this is a valid package. It's not that you can only you can only declare or create a package with more than one subprograms. You can also declare or create a package with just one subprogram also. So this was about package specification. So here, if we just put the name, the code of the subprogram, we will put in something called the package body. Okay. So the package body or definition defines the queries for the cursors and the code for the subprograms, right? Variables constants are the same. I mean, they will be just single line, right? A variable when you declare a variable. So the same thing will reside in the package specification, and you have to put the same thing in the package body also. Where it differs is basically the subprograms and also the cursors. If you have a global kind of a cursor. So the package body, the same thing. Uh, yeah, yeah. Just come here. So we had created the package here. That means the package specification here. Now we create the package body here. So in the body, we again now we put in the code for our procedure. Earlier it was just this much, right? Now we define the procedure inside the package body. Okay. Understood what is a package body and about what is a package specification? Few points. Okay, okay. See, this is a procedure, right? Find underscore sal. This is my package body. Okay. So when I say that I'm going to create a package called emp underscore sal, I have to create two different sources. Okay. One is a package specification. One is a package body. So first I have to create the package specification. So I'll just put in package specification will be created and compiled first. Okay, then only the package body will work. Okay. Second thing, both the age spec and the to be compiled. A package spec can exist without the body, not vice versa. Okay, let's go back to our package. So we are going to create a package called emp underscore sal. That means we are first going to create the package specification. So by specification, I mean in package specification, we'll just have the names of all the different units, subunits which are there inside the package. It might be a package can have three procedures, three functions. It can have a cursor and all that. So here we will, in the package specification, we'll just give the name. We'll just give the name of the procedure. Okay, we are not defining the procedure here. We're just giving the name of the procedure along with its um, parameters, right? In the package body, we are going to put in all the code for the procedure. This procedure doesn't exist anywhere else. Okay, maybe that's what you are finding confusing, right? This is a procedure that is being created inside this package itself. Okay, this procedure find underscore sal is not existing outside the package. Okay, understood? Was that your doubt? Yes. So you cannot, create a procedure or a function somewhere outside and then call it in the package. Doesn't work that way. Okay. So while while creating the package, or I mean, subsequently you can keep on adding procedures and packages to the procedures and functions and anything else you want to the package. So first you add it to the package body, sorry, specification, and then you add it to the body. So coming back to this one, find underscore sal is our procedure. We just gave the name and the input parameter in the package specification, and then we actually put in the code for the procedure in the package body. That's the difference. Okay. So package specification should be created and compiled first, because a package body without the package specification will not compile. Okay. So precedence is taken by package specification. Both the package spec and the package body have to be compiled separately. They get stored separately. Okay. And they're two separate sources. So this is something which is simple, yet people sometimes, beginners sometimes forget. So why do we do all this, right? We can have procedures and functions outside and keep calling them as and when required, right? Because when we put in a procedure in a package, we have to call it like exec package name dot procedure name. Earlier, what we used to do, we could just execute find underscore cell, right? But here in this case, we have to, whenever we want to execute this, we will execute this as emp underscore cell dot find underscore cell. This is how we execute procedure, which is created and defined inside a package. Remember this, okay? So, what are the advantages of uh, having packages? Packages give us the advantage of modularity. That means it lets you encapsulate all logically related types, and each package is easy to understand. Interfaces between packages are simple, and so basically the thing is, say your database is associated with a bank. Okay, so a bank has a loan product, a bank has a has a home loan product, has a car loan product, has a personal loan product. So the various considerations, various logical requirements and the functional requirements are different for all these three different types of products, right? So we can have a package which contains all the generic home loan related logic, right? You can have procedures, functions, and everything just for the home loans. Similarly, we can have another package just for the car loans and so on. So this is what is the number one advantage of having and having packages and creating all our code inside it, because as a developer you are not going to be associated with this database for forever, right? So whoever comes in new, he or she can easily go through the package and understand, okay, this is related to this, and this is how all these codes are related. So it gives you the advantage of modularity. Easier application designs, the same thing is the interface information in the package. You can code and compile a specification without its body. Then stored subprograms that reference the package can be compiled as well. You need not define the package bodies fully until you are ready to complete the application. Okay. So while creating, I mean, it is pure development, right? While you're developing from scratch, you first think of the structure, and then you go ahead with filling it up with your code, right? So the structure, you can put it in your package specification and compile it, so it is there. So next, your next step becomes a little easier. Information hiding. So these are all your OOPS concepts, right? Abstraction, encapsulation, and all those. So information hiding means abstraction, right? So we can have our types, items, subprograms in a package. We can create them as public or private. If by default it is public, if we want to keep it as private, you have to give the keyword private. So if it is private means it is. Yes. So private means it is only accessed inside that package code. You cannot access that. That means something like you have a procedure, or say you have a function which is going to be accessed by the other three procedures inside the package. So you create it as a create private function, right? But those three procedures you have created as public, right? If you don't mention anything here, that means it is public. By default, it is public. So that means the three procedures can be accessed like this, right? The three procedures can be accessed outside, but that function, that particular function, which is a private function, will can only be accessed by the three procedures inside the package, right? Understood? Different between private and public. Yes. Yeah. Yes. So the package hides the definition of private subprograms only. This is the same thing. Added functionality, what does that mean? Packaged public variables and cursors persist for the duration of a session. So they can be shared by all subprograms that execute in the environment. So variables also can be public or private. By public variable, some you mean what you mean is if you create a variable on top of, I mean, in the package specification itself, right? That means that variable can be accessed something like where is the specification? Yeah, here itself, right? Create package this. Let me have a variable also. L var number. I'm just creating a variable here. I'll I mean copy the same thing in the package body. Then what happens is I can also in some other code or in some other package or in some other procedure, I can access this particular variable. Can access this variable. Okay, so this is called a global variable. Right? Global variable. Like I access the procedures and functions, I can access the variables also. Similar with everything else. Okay, whatever you declare in the package specification, explicitly you can consider it as a global variable. But inside the procedure you have declared here, right? E underscore sal, right? This is a local variable. So this cannot be, this is only used inside this particular procedure, find underscore sal. Although this is also inside the package, but this is inside the procedure which is residing inside the package. So this is a local variable and you cannot call this somewhere else. Understood the difference between global and local variables? Yeah. So that also is a added functionality, better performance when you call a package sub. This is very important. When you call a package subprogram for the first time, the whole package is loaded into memory. So later calls to the related subprograms in the package require no additional disk I/O. Also, packages stop cascading dependencies and so avoid unnecessary recompiling. Right. So I I create and compile my package. So how many ever times I keep executing the find cell procedure, it is not going to compile it again and execute, right? So IO consumption is kept to a minimum. For example, if you change the definition of a packaged function, Oracle need not recompile the calling subprograms because they do not depend on the package body, right? So that's about packages. So packages are the most. Okay, just a minute. I'm getting a call. It's a very regular feature, and we obviously any PLSQL developer will use packages, right? So this is done. Now let's come to something very interesting: collections and records. Okay, whenever we are yesterday we saw something like percentile type, percentile row type. Here also it is written, right? Percentile type and percentile row type. So this brings us to something called collection and records. So you understand collections, right? Where I mean it's a composite data, more than one values in a single considered to be a single data, right? A composite data type stores values that have internal components. You can pass entire composite variables to subprograms as parameters, and you can access internal components of composite variables individually. Can be either scalar or composite. Okay, this is all very theoretical. Yeah, I know. You won't understand. This is very theoretical. Okay, okay. You understand what is a scalar data and what is a composite data? Okay. So scalar data is just single value, right? You create a, I mean, you declare a variable and put single value into it. You declare a variable as a number, and you say for a function which adds up two numbers, right? You declare two variables, and the third variable prints gives you the sum of the numbers, right? So these variables are getting assigned with scalar data. Whenever you run the function, you give, say, the first variable value, first input value should be 15, the second input value should be 20. So they get associated, and the function gives you the value 15 plus 20. What about composite? Look at this variable. Okay, the same procedure which was there in our package, right? It is saying find underscore cell procedure. There is one variable we are declaring called e underscore sal. And what is the data type that we are giving? We are giving it a data type of employees table, salary column, percentile type. Okay. That means whatever is the data type of this particular column in the table definition, this is my variable should have the same data type. What does it mean? Today, say it is number, right? Tomorrow it is, say, varchar. So today it'll this my variable will be a number data type variable, but tomorrow it'll become automatically it'll become varchar data, right? Understood the difference? So this is yeah. So this is not a scalar data type. We are not hard coding the data type, right? We are making it dynamic. So this is called a composite data type. So so what are the various collections? So collection by definition only it means more than one object in a single. I mean more than one, right? A collection will have, say if it's a collection of numbers means it'll have more than one number inside. So in a collection, the internal components always have the same data type and are called elements. So those are called elements. So we can only have collection of the same data. We cannot have a collection which will also have number and which will also have date elements, right? So we can either have a collection of number elements, numeric elements, and we can have a separate collection for the date elements. So you can access each element of a collection variable by its unique index with this syntax. To create a collection variable, you either define a collection type and then, okay. So we'll all these things will be simpler when we check in the examples. Okay. Let's see. First type of collection is called associative array. This is in Oracle or index by table. So let's check one associative array. Declare type. Okay. Population is table of number indexed by varchar. So I'll just, okay, it is given here. So we are creating a collection here, okay, called population. Hmm. What are the various, uh, definition or descriptions of this? This is going to be a table of number. Table means it can have multiple rows, right? So this particular variable can store 5 or 500 uh, values, right? One variable can store more than one value. That's what a array is, right? Array, you must be familiar with what an array is, right? It's very basic concept. So this is how an array is declared inside Oracle code. Population is table of number. Number is the element data indexed by varchar 2. Okay. So then what do we do with this? First we create the data type and then we associate a variable to the data type, right? So this is my type. Yeah. Okay. Okay. Fine. No worry. Let me start again. Collection. Okay. So variable when you declare, right? One variable will store how many values? Then keep answering me so that I will keep it. Scalar. Okay, you understood this thing, right? Scalar and composite. That one you understood, right? Yeah. So here also it is, although it is composite, it will all this is also going to store only one value. Why? Because we are giving it as percentile type of the, yeah. But same thing we can do. I mean, there is a way of, because sometimes it will be required. You will later on find out. Sometimes it will be required that you create a variable to store multiple values. Okay, because say, uh, for example, okay, you have a source table and a definition table, destination table, and this is a very real time example I'm giving. Okay, pay attention. You have a source table, you have a destination table. The source table has 100,000 records. Okay, the destination table is empty. Your task is to take all these 100,000 record data and put it inside the uh, what you call the destination table. So there are multiple ways of doing it, right? You can have multiple inserts and s- s- you can just write a simple insert as insert into destination table values, select star from source value. But for 100,000 records to be inserted from one table to another table, it is going to take a lot of space. It is going to take a lot of storage. So what do we do in those cases? I mean, you can get this done by the simplest method, but that is going to cause a lot of problems to the other people who are working on the database, because ultimately the database is going to go slow. So what do we do in these cases? We perform something called a bulk collect. Okay, that means we keep inserting data from the source to the destination. Say 1,000 records at one time. Okay, we first pick up 1,000 records. Okay, put it into a variable. Pay attention. We create a procedure, and inside that we pick up 1,000 records from the source, put it into a variable, single variable. Okay, a single variable will contain 1,000 records. Do you understand? So it's not your normal variable, right? It's a collection. Understood? Yeah. So what do we do in those cases? We pick up 1,000 records from the source table, first 1,000 records, put it into our collection variable, and then we go and dump it into the uh, destination table. Then we clear the collection variable. We go for the next set of 1,000 records, put it into the collection variable, and so on. So you understand what is a collection variable now? Good. So that collection variable could be of three types. Okay, it is either an associative array. So before the type or type and all, you can just check here. Ignore this. This is just a scalar variable. This, okay, this is my, say, the example I gave, right? this is my variable which holds the records, 100 records. But what is population? This is my variable. That's fine. This is my collection variable. Okay, associate here it's a associative array variable. But and we gave the data type as population, right? But what is population? So first we have to define what is population. What is the data type population? So data type population is a table of number, okay, and indexed by varchar. That means this data type will has the capability to store a complete table, right, of numbers, number data, but indexed by varchar. Okay, so it will have two what you call two columns. One will be a number and one will be a varchar. So currently population has nothing. Okay, we just defined the data type and then we created a variable on the particular data type. Still the variable is empty. Okay, when are we going to uh, populate it? Let's go into the begin. Okay, city underscore population smallville equals to, we are assigning value 2000 here. So what are the value pairs? Varchar is the name of the place, population is the, this is the number, right, the numeric data. Are you able to understand? City, yeah, for city underscore population is a variable. So index by varchar, that means, sorry, this is how it will be assigned. The value will be assigned to the variable. So similarly, you can assign. Okay. So something it is doing, it is, you can print the particular and all, but that's okay. I mean, that is for something else. Understand how you first declare the type, then the variable, and then you assign values to the variable. That's the simple sequence that you have to maintain, right? So there is a, yeah, there is a syntax for associative array. So this is only one type of collection. What is the next type of collection? Next type of collection is called V array, varying array or variable array. Understood the associative array? Now this is a separate type of collection. A V array or variable size array is an array whose number of elements can vary from 0 to the declared maximum size. So in a V array, there will be a limit of how many values it can hold. Okay. So how is it declared? Type foursome is V array limit 4. So it can hold up to 4 values of varchar 215. So this V array foursome can have 4 values of varchar 215 types, right? So that you understand varchar 215. So it's a, yeah, it's a string will, yes. So say you are going to give names. So you can have 4 names and each name should not exceed 15 characters. So similarly, team foursome. So this is the type. Then we'll have a something like a variable in which uh, yeah, which is of this type, and then we can assign these values, right? Understood? Simple. Yeah. And then the most interesting one is the nested table. Now this is the be all of all collections. Okay, so as you see in in the name itself, it's a table. This is a V array. That means it will only have number of elements, right? This will hold whole rows. Okay, the example that I was giving, right? One table, source table, one table definition table. Say the source table has 20 columns, right? When you take 1000 records, when you bunch the first 1000 records into one collection, it will have the data for all the 20 columns, right? So in that case, your variable should be a nested table type. a column type that stores an unspecified number of rows in no particular order. So there is no limit to how much the nested table can hold, right? When you retrieve a nested table value from the database into a nested table variable, gives the row consecutive indexes starting at 1. So this is all implicitly done. Okay. So how the data is stored and data is retrieved inside a nested table, we don't have any control over it. Let's see a let's see an example. First, you create the nested table type, right? Type, the name is roster, is table of varchar2, right? Names, these are the names that are going to be names is a variable of the table, sorry, of the type roster, and this is the these are the values which are assigned to it. So something maybe somewhere it is getting printed, right? So this is how. So here it looks the same as VRA, right? VRA also we were doing the same thing. So but in nested table you can have multiple column data also. Okay, so nested table is obviously more comprehensive and obviously more powerful than a VRA. Remember the remember the example that I gave you, right? So but we will actually go to bulk collect and we will see how it is done. Okay, understood the various collection types: associative array, V array, and nested tables. Okay. Next, there's a very small concept called temp tables or temporary tables. Temporary tables are very much like an ordinary table with an only one vital difference of not having foreign keys related to other tables. It contains all the attributes of a table, including information about rows and blocks, triggers, join kernels. Okay. So we can create a temporary table like this, right? Create global temporary table. And so why do we need a temporary table? When it says that it doesn't have any foreign keys in it, you cannot create foreign keys in a temporary table. That means this table cannot be uh, in structure or in definition linked to any other permanently residing tables, right? So that means this table is a temporary table. So the data will be wiped out. I create a global temporary table in my session. I work. I mean, I insert data into it. I take out data into it, and all that. I can do it, right? But once my session is over, this table is also gone. This doesn't persist, right? So that's why if I have a foreign key with some other table in this, doesn't make any sense because that's a waste of storage and I cannot use the primary key of this table into any other foreign key because this is a this is not a stable table. This is a volatile table. Once the session which creates the temporary table, once this session is over, the table is gone. Okay, understood? Yeah, why we need it? We do need such tables sometimes, so that in concept of staging tables, we use it. Okay, what is a staging table and all? That is like a little advanced concept. You will get to know when you start using one. Okay. So this temporary table actually doesn't. I mean, there is a temp uh, segment in your database. It resides in the temp segment. Okay. Next is, this is also very interesting. While discussing cursors yesterday, we were getting this term, right? Cursor variables. So this is called ref cursor. What is a ref cursor? This is a dynamic cursor. Means a select query is find called this kind of cursor. Hmm. What is a cursor? Cursor is nothing but a select query, right? An explicit cursor. We declare cursor C1 is what selects something from some table, right? Where some condition. That is what is a cursor. What if we don't know the select query while creating it, while creating the cursor? Okay, we want the select query to be defined dynamically, that is at runtime. In those cases, we use this concept called ref cursors or cursor variables. Okay, are you getting any idea with this? Let's see the example. Okay, so this is a package we are creating. We are creating the type. This is the name of the type is ref cursor. Is ref cursor. So ref cursor is a data type, right? Basically, people will, is cursor variable a cursor? No. Cursor variable or ref cursor is a data. Ref cursor is a data type like number, like date. So ref cursor is also a data type. How we use ref cursors? We first create a type, okay, of data type ref cursor, which returns employees percentile row type. What does it mean? Employees percentile row type means how many ever columns are there in employee table, this cursor will have all of those columns in its definition. Are you getting this? Okay. So here we created a ref cursor, a ref cursor type called mcur type, and we are using that same as our in out parameter in procedure MCV. How? In out this. What are we doing if choice equals to 1? Yes. So at runtime, see what we are doing. We are talking about dynamic cursors, right? We creating or are we associating any select query anywhere in the declare? We are not, right? We just created the columns for the cursor, right? We didn't put in any data. We are putting the data dynamically. When the procedure will be run, it will either create any of these three. It will create any of these three scenarios. It will go into either when commission is not null, or when salary is greater than 2,500, or where department is. So if commission is not null, then it will take the values like this. Whatever choice. Sorry. Choice is the our input parameter, right? So if say the choice is given 1, then this is the select query which will be associated to the cursor. If choice is 2, then this is the select query which will be associated to the cursor MCV. If choice is 3, so basically difference is we can dynamically associate the select query to a cursor variable, right? For a cursor, what was happening while defining the cursor itself or while declaring the cursor itself, we had to give the select query, and we cannot change the select query anywhere else in our subsequent code, right? But here we can dynamically associate the select query. We don't have to define it anywhere in the declaration. Understood? Understood this? Okay, so I was checking the syllabus. So these are the three things which are remaining in the whole syllabus for you. Okay. Do you want to go through whatever we have discussed in the weekend and come back to me on Monday? We'll have a final session on Monday, right? And I will cover these three small things also. So if you want, we can connect on weekend also, but I don't think that's possible with you, right? So go through everything. Okay, the whole note I'm going to share with you now. Go through everything. These three small things I will discuss with you on Monday first, and then we'll whatever date, whatever doubts or anything that you want to be rediscussed, we can do it. Okay, we'll have a final session. I can give you. See, I won't suggest that you have a PDF and go through it or buy a Oracle book. That is pretty boring. Okay, I will suggest which sites, which websites you should. I will have this ready for you on in that final session. What are the websites that a Oracle PL SQL guy should uh, refer to? Okay, for theoretical knowledge also and for practical knowledge also. I will suggest a few. So just go to the website and whatever concept you want, you search for that. Like you want to understand how, I mean, what is bulk collect and how it is done. You just search for bulk collect. You will get the proper uh, some sort of reference. But understanding and all, see, understanding will only come when you actually do it yourself, or someone like me, someone is going to sort of explain everything to you, right? If you just saw, if you just saw something like this, would you have understood? Even with the theoretical knowledge, you wouldn't have understood this, right? So if someone who understands this previously will come and discuss this with you, then you can easily understand that. So similarly, I will give you a very nice and very informative links, websites actually, which will help you in everything related to PLSQL. Okay, SQL also and PLSQL. Yeah. So go through all the notes. Okay. If you have any questions, have them ready. Maybe we will first take your questions in the final session, and then we will complete these three small things. These are this all these three things together will not take more than 10-15 minutes. Okay. We'll share it with you and see you on Monday. Hopefully, okay, Monday. Okay, I'll let you know. I don't know about Monday. Um I mean, first half or second half, I don't know. But yeah, definitely we'll have it on Monday. Yeah. Bye.